Today's topic, a new warp drive, part 1. Hello and welcome to Astron-X, researching and discussing things of science, technology, and space. Thanks for stopping by. I'm Todd, your host. In our last warp drive video, we introduced and discussed the basics of how the Alcubierre warp drive works. And within 8 months of publication, that video reached over 1 million views. Thank you. In this video, we will be introducing and discussing yet another version of the warp drive, one that is also based on Alcubierre's work. Additionally, at the end of this video, we will be addressing many of your warp drive questions directly. Now, wait until you see what we have in store for you. This is the exciting part. Of course, there's nothing new about the concept of a starship or a warp drive. Thanks to Star Trek and Star Wars, we know them well. And of course, science fiction has inspired many a scientist to explore new technologies. Hence we have lasers, cell phones, warp drives, and more. Warp drives? That's right. Thanks to Dr. Miguel Alcubierre, who had set the stage, a new form of space drive is now underway. You see, like most of us, he too yearned for the day when something like a star fleet could step out of the realm of science fiction and into the realm of reality. However, some of you are doubtful that the future will ever come to pass. What I can tell you is this: despite all that there is and has been happening in the world today, science is and has been advancing. So, what about the future then? Are we now able to build some of these science fiction style technologies, such as the Enterprise, but for real? Well, what we're about to discuss may actually surprise you. That's because we may be more advanced than you might know. The drive we're about to discuss is an advanced, multifaceted system that collectively functions as a whole. However, this is only the beginning, so listen carefully to what we're about to discuss. You see, the future has long since been coming, and that's due in large part to the fact that it's been 50 years since anyone has walked on another planet, aka the moon. Meaning, we're more than ready for something new. In fact, I would venture to say that the time has come, therefore, may the future finally arrive. And with that, let's get started. Introducing the Alcubierre-Froning Warp Drive, a truly faster-than-light drive. Now, in 1980, a certain Dr. David Froning, a man ahead of his time, conceived of a radical new form of propulsion, a departure from the norm, called the quantum ramjet. At the time, Dr. Froning did not know how one might go about building this drive. Fast forward to 1999, seeing potential in the Alcubierre warp drive, he combined his work on the quantum ramjet with Alcubierre's work. The result was an entirely new form of propulsion. Not merely another kind of reaction drive as the original ramjet was, but something new altogether. We call this the Alcubierre-Froning Warp Drive. In contrast to the Alcubierre-White warp drive, though it is well founded in actual science, it is not an off-the-shelf ready-to-use, as it still requires much work. On the other hand, the Alcubierre-Froning Warp Drive is a much more doable drive, requiring much less refinement. Additionally, the Alcubierre-Froning Warp Drive utilizes real science that just happens to resemble science fiction-style technologies. Actually, this new drive differs in many ways from the Alcubierre White Warp Drive. For example, in both Star Trek and Star Wars, they make use of energy shields.
Shields up! Take this!
Well, it appears that they got that part somewhat correct. That's because the most important component of the Alcubierre-Froning Warp Drive is the photon force field. That's right, you heard correctly, an actual photon force field or shield like you see in Star Trek and Star Wars. The photon force field. How does it work and what does it do? It serves both as a shield and a screen and is vital for the following purposes: for eliminating atmospheric friction, for protecting from radiation and debris, for neutralizing mass, for screening away time dilations or shifts, that is, unwanted time travel, for screening away other relativistic effects, for generating an acceleration assisting effect, for extracting energy from the craft's motion through the quantum vacuum, and by a combination of several of these effects, allow superspeed travel up to and beyond light speed. Now, as you already know, reality is often more strange and fascinating than science fiction. This photon shield is an example of this fact, as it functions much better than the vast majority of shields depicted in science fiction. For example, the photon force field / shield is not a bubble around the spacecraft, rather it's a repulsive field emanating directly from the surface of the craft. Unlike most fictional shields, this real shield is not a shell or a wall that could be damaged, punctured, or even weakened under bombardment. For example, so, how is this photon force field generated? It is generated by emitting hyperfast pulses of conditioned radiation. What is conditioned radiation? Well, first a little background knowledge. Normally, photons, electromagnetic radiation that is, scarcely interacts with most kinds of matter and does not interact at all with other photons. This may seem counterintuitive, however, compared with the forces that bind atomic nuclei together, photons interact quite weakly indeed. That said, it is possible to create electromagnetic radiation photons or fields that gain the characteristic of other forces, creating, in a sense, hybrid radiation or fields. This conditioned radiation or fields can now interact with the more energetic constitutes of space-time, unlike normal photons. Now, when an unshielded spacecraft travels through the air, it encounters resistance from molecules of air. And when in space, there are swarms of inconspicuous particles which can damage a spacecraft. But by generating a photon shield, all air molecules and debris are deflected without resistance, protecting the spacecraft and allowing for unlimited speed. Additionally, by generating the shield using pulse-conditioned photons, the craft's mass is greatly reduced or even totally eliminated, making the spacecraft nearly or completely massless. As a result, the spacecraft becomes a miniature independent planet and may accelerate at any rate without the passengers succumbing to the acceleration pressure g-force. It is also important to note that by changing the spacecraft's mass, spacetime is repelled and warped in nearly the same manner as in Alcubierre's original concept. One could even say that the shield produces a kind of repulsive gravity, that is, a form of anti-gravity. Is there any force conveyed back to the spacecraft?
How is this done?
Good question. You see, once a photon is emitted, it has an independent motion relative to its source, so that any particles or debris that the photons deflect do not convey any forces back to the photon emitter. As a result, the photon shield gains a truly deflective quality, and thus all kinds of radiation, debris, small asteroids, etc. merely slide off without imparting any resistive force back to the spacecraft. That said, such debris as large asteroids will still be deflected but may slow the craft, and if impacted at a great enough relative velocity, may actually push into the shield far enough to damage or destroy the craft before it can be completely deflected. How does the drive propel itself? Unlike the Alcubierre White Warp Drive, the Alcubierre-Froning variant does not require a torus. More importantly, as already stated, this unusual new form of propulsion is able to draw its energy directly from the fabric of spacetime, which is not empty nor energyless, but is indeed very energetic. You see,
its energy surrounds us and binds us.
Anyway, surrounding us everywhere are both positive and negative pressures. Particles and energy, they are. The negative pressure aspect of spacetime would tend to pull everything apart, but is normally counteracted by the positive energy aspects of spacetime. As basically already stated, by utilizing conditioned photons to deflect all kinds of radiation without resistance, the craft's mass is greatly reduced or totally eliminated, and the electromagnetic permeability of spacetime is reduced, which increases the speed of light in and around the spacecraft. It is noteworthy that an increased speed of light in and around the spacecraft is a common feature of all the Alcubierre Warp Drive versions, original included. Now, the amount by which the negative pressure multiplies the spacecraft's acceleration is dependent on the spacecraft's speed relative to the primary or universal reference frame, no other frame. So in this way, the craft is now in its own independent region or self-contained block of energy that does not mix with the surrounding energy. This block of energy still interacts with surrounding energies to a limited degree, but again does not mix. This means that a spacecraft traveling at a constant speed will experience no acceleration assistance. Therefore, a minimum baseline thrust is necessary in order to assist the spacecraft's speed. Emitting conditioned radiation both backward and forward with a slight asymmetrical bias will produce the greatest acceleration assisting effect in a given direction. Despite being massless, the shielded spacecraft will still be attracted toward a planet or other massive body, as it is energy, not mass per se, that both generates and is attracted by gravitation. Therefore, a spacecraft must continually be accelerated in order to remain in a fixed hovering position above the surface of a planet. Because the spacecraft is now massless, there's no longer any mass to reduce any acceleration. That is, acceleration directly corresponds to the force on an object, without being reduced by the object's mass. In mathematical terms, the equation for acceleration becomes a equals f rather than a equals f divided by m, as it is for massive objects. In other words, even the feeble thrust of a photon drive could generate enough force to hold the spacecraft up against Earth's gravitational attraction. The necessary beam drive need only be as intense as the sun on a warm sunny day. Now, unlike photons, a shielded and thus massless spacecraft will not instantaneously accelerate to light speed, as the craft's accelerating motion through space-time would still produce shock waves of Cherenkov radiation. Even shielded, this creates a measure of resistance, even though that resistance would still be massively reduced in comparison to an unshielded spacecraft. Photons, on the other hand, lack such shock waves and thus accelerate instantaneously to light speed. There will be times when a spacecraft will need to deactivate its shields whilst remain hovering. However, with the shields inactive, the beam drive would need to be so intense that it would, to put it mildly, roast the ground below. Therefore, in these cases, a spacecraft must make use of another kind of drive, a gravitational drive, that is. That's right, a spacecraft must be able to control and even generate gravity synthetically, as they do in sci-fi. What is going to power the Alcubierre-Froning Warp Drive? That would be two separate sources of energy. One, quark fusion for gravity control, and two, energy extraction via the shield, that is, the photon force field. Again, the photon force field consists of several related systems that function together as a coherent whole and is what allows the drive to go faster than light. What about construction materials and techniques? As with any spacecraft capable of FTL travel, there will still be stresses on the spacecraft, requiring that craft be so designed and constructed as to be able to endure such stresses continually and for many years. As was illustrated in one of the more recent Star Trek movies, Beyond, a starship must be able to endure direct impacts on the surface of a planet without totally destroying it. Therefore, it must make use of condensed alloys not yet discovered or engineered. Furthermore, a starship must be able to endure years of operation without being able to stop for repairs. Think about it. Where would you pull over for repairs in deep space? You won't. The fact is, the crew of the starship must be able to make repairs on the fly, so to speak. That's why a starship is a mini world in its own right. Okay, what about life support? As you already know, space is utterly massive. Even with an FTL-equipped starship, traveling between systems will still take a very long time. Therefore, we will have to anticipate that we will be traveling through space for several years, if not a decade or two, without being able to stop for supplies. So the starship must be able to supply its crew with all their needs, such as the air to breathe, the food to eat, water to drink, hygiene, sleeping quarters, personal space, and so on. Unlike here on Earth, we must recycle everything we can. And all these things and more must fit within the starship's hull. So, who's going to operate the starship? Man or machine? It's not who, rather it's what will be operating the starship. Let's face it, we are incapable of operating a starship at high speeds safely. Moreover, though humans will be inspecting and maintaining a myriad of systems, it's just not practical to rely on humans solely. In fact, it is better to have humans check and recheck and maintain vital systems in real time. Therefore, the starship must make use of artificial intelligence for navigation, life supports, etc. systems. Of course, humans will always be able to override the AI if needed, though not very likely to be needed. What about hazards of space travel and visiting alien worlds? As long as the shields are active, there is no threat to the starship. However, should gas, dust, or even asteroids be able to reach the surface of the starship, this means that the shields must have failed and the starship is in grave danger. As far as alien worlds go, well, this is where we have reason for concern. Note, not fear, simply concern. We may come across a habitable Earth-like planet that, for all intents and purposes, has the appearance of being benign. However, the truth is, we just don't really know. For example, we may encounter a seemingly harmless dandelion resembling one found here on Earth, exactly. Though it may appear completely harmless, the fact that it developed on an entirely different world means that it may chemically be harmful to humans. Everything must be tested and retested. We must not take any undue chances, nor can we afford to be irrational, since it is a long way back home. So the starship is a Starpolis, Star City. As I've already stated, and you can see, a starship, again, is a mini world in its own right. What would a takeoff look like from inside a shielded starship? We've been working with Oliver at Galaxy4D.com to create realistic warp drive mechanics for his full-scale multiplayer space simulation game. Since the game is based on the same laws of physics that govern our universe, this means what happens in real life also happens in game, which is why we asked Oliver to create this video showing you what it actually looks like. Enjoy. As promised, let's take a moment to address some of your questions from Warp Drive Part 1. Will gas and dust be a threat to the spacecraft? For the Alcubierre-White Warp Drive, yes it will. For the Alcubierre-Froning Warp Drive, gas and dust will not pose a threat to the spacecraft whatsoever. However, this does not mean that the spacecraft will be able to fly through a planet, a star, or especially a black hole. Is a warp drive a time machine? Yes, according to relativity, any faster than light travel is equal to time travel. What happens to the crew inside the warp bubble when the starship enters hyperspace? They relax at the fact that they're still alive. Now, joking aside, seriously, nothing happens to the crew because they are now in their own absolute independent reference frame, their own space-time energy bubble where space-time is normal. Will the crew of the starship come back younger than the folks on Earth? As long as the starship is properly screened, there will be no time dilation. When the crew returns, they will have aged no more or less than the loved ones here on Earth. Will a warp drive-equipped starship be able to collide with asteroids? That depends on the mass of the asteroid, or more commonly, the comet. With regards to the Alcubierre-White warp drive, that would be bad news. For the Alcubierre-Froning warp drive, that depends on the mass of the asteroid, or more commonly, the comet, and on the speed of the starship. For objects with masses on the order of hundreds of tons or greater, yes, they may be able to push into the shield far enough to impact the starship's hull. Again, this is why an AI is vital, as such objects must be avoided. Can a warp drive be activated near a planet, a star, another spacecraft, etc.? Actually, the warp drive will always be active except when safely landed, and even then it could be safely left on, with the only problem being that it would stop you from entering your starship. However, light speed may only be approached and exceeded far in outer space. Otherwise, planets, bits of star, or other spacecraft may be pulled in. Will spacetime contract in front and expand in rear of a spacecraft? Yes, however, the expansion and contraction is not what propels the starship, and is in fact unwanted. You see, the expansion and contraction is akin to the rarefaction and compression of air behind and in front of an object moving through the air. Warping spacetime in this manner, expansion and contraction, subtracts energy from the available energy needed to propel the spacecraft. How does the starship decelerate and come to a stop? By thrusting forward in the direction of movement. Will we have to use negative energy? Yes, but as we discussed earlier, spacetime itself actually provides the negative energy that is needed. When in the warp bubble, does the spacecraft or space-time move? Yes and no. The spacecraft does not move within the bubble. However, space-time is deflected around the bubble with minimal or zero resistance. To be continued. Well, that concludes this video. the Alcubierre-Froning Warp Drive Part 1. We want to thank you for watching. Be sure to watch for Part 2 and subscribe, as this will help us post more videos more often. Till then, keep wondering about space.